Welcome back for another video. This is going to be on 3D Mill, Lesson 9, Exercise B. Would be the drawing that you see here on your screen. So let's go ahead and get started with this. Okay, so if I move that to the side, first thing I need to do is I'm just going to pick my mill quick. I could draw the part first, but I just want to pick that quick. Go to my wireframe. And let's see. So first what I'm going to do is for this one, I'm going to make this out of a solid as opposed to my last video, which I made out of a surface. So I'm going to actually need to revolve a solid, and then I'm going to need to subtract it from another extruded solid to create this cavity. So to start out, I am going to just draw this profile, this half of this profile, and I'm going to start at 0, 0 to do it, and then I'm just going to translate it over. Just because it's easier with these numbers, the way that it's dimensioned, to draw it at 0, 0 and translate. So let's go ahead and start off with that. And I'll start at 0, 0. And I'm going to go 0, comma 0.35, enter. And we'll go to 0.75, comma 0.35. And 0.75, comma 0.9, actually it's going to be 1.5, comma 0.9 again, and then we're going to go to 1.5, comma 0.45. Okay. At this point, we don't really have anywhere else we can go. We don't have any other locations here, so I'm just going to draw that line straight out. So I'm going to draw this out far enough where I know it's going to intersect that angled line. And now what we're going to do is we'll draw this arc in here because we know where the center of that is. So we'll start by drawing this arc in here, and then I'll just add this line and we'll trim everything up. Okay, so let's pick a circle. And it looks like that is at 2.875, comma 0.45. Our radius is 0.375. Hit check. And then we need our angles. So if we look at this print, this is 120, so that means this has to be 60 in order for that to be 180 along that straight line. So if this is 60, half of that is 30, so it's a negative 30-degree angle there from 3 o'clock. So I'm just going to type in a negative 30. Click my line, hit check. And then I do the same kind of math here. So from 3 o'clock, 30 degrees plus 20, or 120 is 150, plus another 60 is going to be 210. So I'm just going to do a positive 210 and drag that line and draw it. And then I'll do that last line right here, which is 4 inches. So we'll go 4.0, comma 0. Oops, 4.0. Oh, my fast points aren't coming up, so I'll click here. 4.0, comma 0, enter, and I'm just going to draw that straight up. And I'll just trim all this up. Trim that, trim that, trim that, trim that, trim that. And there we go. So there is our profile. Now I still have to add some radii, as you can see there. So I'm going to add those in. Looks like we have 2 3/8, actually just 1 3/8 radii. So I guess in that case we'd call it a radius. 375, and there we go. Alright, so now I'm just going to add the 0.125 radius to all of these edges. I think they all get it, yeah. I don't want to accidentally put it on any that don't get it, but it looks like they pretty much all get this. Oop. And I believe that is it. So that should take care of it. Hit check. And I am going to add my line down here to revolve around. Okay, I'm going to hit my check mark. All right, so the next thing I need to do is I need to offset this over. So it needs to be translated 380 this way and it needs to be translated down 1.25, so it's in the center of this block. So I'm just going to hit transform, translate, and we're just going to do 0.38, oops, 0.38, not 3.8, and negative 1.25, enter. That looks good. It's a move, and I'm going to hit check. Okay. All right, so there's my profile. Next, I am going to go to solids, and I'm going to revolve this thing. So it's asking for my profile. I'm going to hit check, and then it's asking for my axis to revolve around, and that looks good. Okay, so I have that revolve. And next, I need to create a block. Okay, so what I'm going to do to create this block is I'm actually just going to pick block here. And this is a really easy way to create one of these. And if I just look, see what size my block is, 4.75 by 1 by 2.5. So if I say my length is 4.75 by 2.5 by 1. Actually, it's going to be a negative 1.0, so that it goes down in the negative. My base point right there, and that looks good. All right, so I'm going to hit check. The next thing I need to do here is I need to boolean this. And basically what that means is I'm going to subtract this one from this one so that it gives me a cavity. So I'm going to pick my boolean command here. And the target body is going to be this, and my tool body is going to be this. And I need to select that. And there we go. And there you go. So there is the cavity that I am looking for. And I'm going to go ahead and hit check. I'm also going to go to top, and I'm going to select that profile. I'm just going to move that to a separate level. I really should have created that level first, but it's never a bad idea to move this stuff before it gets too out of control when you get too much stuff on there to separate. So I'm just going to call this revolve profile. And I'll move, I can always just do this. Where is it? There it is. Remove that to revolve, check. Okay. I'm going to call this one solid. Turn that one off. And now I'm going to create my boundary around here as well. So and if I'm working on that, I can just click on my wireframe and do my silhouette boundary. Oops. That's actually not what I wanted. Silhouette boundary and selection. Oh, that's why it's not working. Undo. Yeah, so what I can do here is curve on one edge. So I can't use a silhouette boundary because it's going to give me the outside of the part. I wasn't thinking. I was thinking like I was still using a surface, because then it would have worked just fine. Could have done a project too. There's a couple different ways you can actually do this. So there is my boundary. So I'll leave that on for now. And let's set up my stock. Okay, so my stock, easiest way to do this, just pick all solids. Hit check, and it just makes my stock the same size as my solid. All right, we are ready to do some machining to this. Okay, so to start out, what I'm going to do is go to my toolpaths, and I'm going to use my OptiRough like I did in the tutorial. And pick the OptiRough. I'm going to actually regen these and make these 0.01, 0.01, and let's select. Now, one of the cool things you can do here, if you have these solids, I should be able to hit Shift, and it will pick all the solids in this cavity. All tangent solids. So this selecting options here. This has grown exponentially over the last few years in Mastercam, and it is fantastic, especially when you're working with 5-axis programming. So I got all the solids all the faces, solid faces that I want. So let's hit end selection. Next, I'm going to go to toolpath control, select my boundary chain, hit check. Strategy, I'm going to stay inside of this. I'm going to stay inside of the compensation. My tool, we are going to use a filter. I'm going to use a bull mill, and I'm also going to make sure I'm in my right aluminum. And I should have a 1/2 inch with an 1/8 inch. Yeah, 1/2 inch with an 1/8 inch radius on it. Feed rate for something like this, I'll probably run it around 80 inches a minute in aluminum at 12,000 RPM. Plunge rate, I can run that probably about 25 inches a minute. Rapid retract is on. My cut parameters, I can step over probably 35% with this without an issue. Step down, we're going to make this actually 100% of the tool. And our step up, we're going to leave at 10%. So basically it's going to step down. Each step down pass is going to take a 1/2 inch. Okay, anything else here? I can put mill vertical walls. I do have some vertical walls on here. Not many though, just on the ends. So I'm actually going to leave that off for this one. We'll go over that in a future segment. Plus this is a rough, so I really don't care if it mills those walls right now. We're going to helix in. That looks good. I'm going to leave that helix radius as is, actually. Maybe make that 0.25. I think I should have enough room for that. We'll see. Linking parameters. This 1.0. The trimming, I'm going to machine each pass. And full vertical retract looks good to me. Arc filters, I'm not going to do much with my arc filters. I'm just going to put these on, and I'm going to make this about 50% and 50% there. Okay, so that looks good. Let's hit check, see what we get there. See if I forgot anything. Let's say that looks pretty good actually. Yeah, that looks good. All right, so that's going to mill it out, and next we need to finish this thing. Now, the thing to remember here is we have an 1/8 inch radius in the corners of a lot of these, so we want to use a smaller tool, ideally smaller than a 1/4 inch, because a 1/4 inch end mill would perfectly fit into that 1/8 inch radius. So we don't want to have full engagement, a 90-degree engagement on that tool. So what we'll do is we'll probably use a 3/16 ball mill so that we're actually cutting around there. We're actually going around that arc rather than just plunging into it. So let's go ahead and use our hybrid path for this. And I am going to actually zero this out and hit shift, select all my surfaces. Toolpath control, we are going to pick our boundary, and everything there looks good. Tooltip, we're going to keep it on center for this, and we're going to go and get ourselves a ball mill here. So I'm going to get a 3/16 ball. And this we're going to have to feed a little slower. Probably only going to be able to feed this at maybe like 35 inches a minute. Still going to go about 12,000 RPM for sure because we have a fast spindle. We need a really high spindle speed for this small of a tool. Step downs. We're going to go, let's make it 5 thou. So the smaller your tool diameter is, the smaller the radius ball mill, the smaller your step down should be. Because if you think about that, the curve is going to be quicker. So it's going to leave smaller, or the bigger your step over is, the higher the scallop's going to be. So in this case, since we have such a small end mill, I am going to change it to 0.005, 5 thousandths. My limiting angle, I'm going to make that 45 degrees. It really doesn't affect much here because I'm going to keep these the same anyway, so it really wouldn't matter much. Everything there looks pretty good. We're going to make the closed offsets for that flat surface. We don't really have any flat surfaces, so again, it's not really a big deal. Transitions, linking, we'll make that 1.0. We'll keep minimize trimming on for this finish pass. Arcs, so we are going to filter these. And we're going to put our smoothing on and keep this at 33, 33, 33, and that should be 34. Okay, all that looks good. We're going to make filtering in all the planes, and that looks good. So I'm going to hit check. And let's see what we get there. So depending on how powerful your computer is, that's how long it takes to generate these toolpaths. This computer actually has a pretty good amount of RAM, but remember we're only stepping over 5 thousandths, so it might take a little while because it's creating a lot of paths there. You can see down here it's actually, there we go. So that looks pretty good actually. So let's go ahead and run that and see how it looks. So that finish looks pretty darn good actually. Now it might not be that good in real life. You don't really know until you run it on how good your surface finish is going to be. This doesn't really do the best job of simulating surface finish, but based on what we see here, that part looks pretty good. Using that 3/16 cutter, if I turn my tool off here, you can see that I really got into those corners good. I don't have to worry about any stock being left in those by using too big of a tool. So that is it. That is our part, and it is finished. So pretty straightforward, just 2 tool paths. Most of the challenge here is just creating the geometry, creating the solids. That's all new for everybody. But aside from that, it's pretty quick work. So that's all I have for this video. If you have questions, feel free to ask me during class, or of course, as always, my office hours are available as well.